Welcome everyone, welcome back to Mathematics. Today we are going to talk through the essential topics of statistics, the concept that form the foundation for higher school and first year university course. By the end of this session, you will have a solid understanding of the data, how it works, how we analyze it, and how we draw meaningful conclusion. Okay, let's go move into it. First, we have to know what is statistics. Statistics is a science of collecting, organizing, analyzing, and interpret data. First, we have to collect the data, organize it, and we have to analyze it. This is the statistics. Okay. Next, we are going to move about types of data. Types of data. Let's start with basics. Data is simply information that we collect so we can analyze it. All data falls into two broad categories, quantitative and qualitative. Which describes quantities or categories is called qualitatives, and which describes deals with the numbers or a measure is called a quantitative. Understanding which type you should work with determines which statistical tools you can use. Okay. First, we have to see the qualitative data. Qualitative data comes in two forms. Nominal data has a categories with no natural order like colors or names. Okay, ordinal data. Ordinal data has a categories that do follow an order such as ranking, satisfaction level. Even though ordinal data has order, the difference between categories aren't measurable. Quantitative data next. What is meant by quantitative data? Quantitative data is a numerical, discrete data involves counts, whole numbers like numbers of students in a class. Continuous data. Continuous data involves measurements that can take a value within a range like height or a temperature. This distinct matters when choosing graphs and the statistical method. Next, we are going to see the measure of a central tendency. To summarize the data set, we often look for its center. The mean is the average. That median is the middle value and mode is the most frequent value. Each measure tells us something slightly different about the data. When to use each measure of a spread. To mean the mean work best when the data is symmetric, does not contain extreme outlier. The median is more reliable when the data is skewed. And the mode is especially used for categorical data where calculating an average does not make sense. Okay, next, measure of a spread. What is measure of the spread and why spread matters? Knowing the center of data set isn't enough. We also need to know how spread out the values are. The range gives us the simplest measure of the spread. Range gives simplest measure of the spread. The interquartile range follows on a middle 50% of the data, and the standard deviation shows the spread around the mean value. This is called standard deviation. Next, graphing data. Graphing data, we have box plots, histogram, pie graph, bar charts. Bar charts, we know that lines are drawn in a graph to denote the bar charts. That is discrete distribution. Pie charts means that is a proportions that occurs in a circle. Histogram means a continuous data, and the bar also in a continuous representation. Box plots, we know that mean, median means minimum, maximum, median, IQR. That is called the graph data, box plots. Next we have box plots is a great way to visualize spread. It shows the quartile, the median, potential outliers. The interquartile range means we know that Q3 minus Q1 captures the middle half of the data. Outlier are usually defined as a point where more than 1.5 times the IQR beyond the quartile. That is 1.5 times the IQR value. Okay, next probability. Probability we have already seen in a previous session. Probability measures how like an event is to occur on a scale from 0 to 1. We start with a sample space, all possible outcomes, and define event as subset of the space. Complementary intersection and the union helps us to calculate more complex probabilities. Next we have going to see the discrete distribution. Discrete distribution is a binomial distribution model suitable with a fixed number of trials, each two possible outcomes, and a constantly probability of success. We use the probability mass function to a constant probability of success. Binomial table or a calculator makes this easier. Continuous distribution, nor it comes in normal distribution. So one of the most important in statistics. It is a symmetrically bell shaped, so bell curve, and fully described by mean, median and standard deviation. Mean median mode is equal, standardly distributed. A standard deviation we can use probability density function and z-score we know that x minus mean divided by SD. SD means standard deviation, comparing the values across the normal distribution. Next, confidence interval. A confidence interval gives us a range of value that likely contains true population mean. It's building using a sample of a critical value and a margin of an error. 95% confidence interval does not guarantee the true mean inside, but if we repeat the process many times, 94% those intervals would be contained in it. For example, estimate population value is 50 plus or minus 3 means that comes under 47 to 53 range. Higher confidence value means wide interval. Hypothesis testing is chi goodness of fit. In hypothesis testing, we start with a null hypothesis, usually a statement of no difference or no effect. The chi-square goodness of fit test compare observed frequency to expected frequency. If the difference is large, based on the critical value, reject the null hypothesis. Regression and correlation. Regression helps us model the relationship between two variables. A scattered shows the pattern and the line of best fit. Summarize the trend. Correlation the coefficient of, or measure the strength of and direction of relationship, and thus R square tells us how much the variation in one variable is explained by other. Correlation means or differences between -1 to +1, positive or negative or zero correlation. Correlation does not occur by caution. That is, if it increases, it also not increases. That is called correlation. Regression means a prediction y and y from x. Equation y cap is equal to a plus bx, where a is intercepts and b is a slope. Residence is equal to actual minus prediction. Okay, I think you have see the quick revision of the statistics. We have covered a lot today, from the data type and the summary statistics to the probability distribution, confidence interval, hypothesis testing, regression. The concept from the backbone of the statistics things and will support everything you learn going to forward. Thank you for listening. I am happy to take any questions or go back over any topic you would like to explore further. Please comment me in the comment box. I will move for it. Thank you for listening. See you in the next class. Thank you.